Today, I thought it might be fun to build a cron scheduler. There's an article by Adam Wiggins called Rethinking Cron. The idea of using a small, lightweight process to schedule periodic tasks in a distributed system is very compelling, at least to me. So that's what I'm going to do today, but with a catch. I'll be using the actor computation model. But you might be asking, why would we do that when we already have tools at our disposal that already do those things at the operating system level? Unix tools like at, batch, crontab, etc., or even Ruby libraries like Rufus Scheduler, whenever, Clockwork, and so on. With regard to cron, it's a great tool, but I think they're more suited for system tasks like backups, updates, log rotation, etc. A Ruby process for application processing is more appropriate, in my opinion. And even though there's already Ruby libraries that do similar things, I find that coding something on your own can help you understand certain concepts. And many times, already existing Ruby libraries have their own flaws, and sometimes I just want to roll my own. Here are some of the dependencies I'll be using today. The actor library is built by Nathan Ladd, one of the principals of the Eventide Project. It's a Ruby implementation of the actor model. And fun fact, Eventide uses the actor library extensively in its stack. Next, we have parse-cron, because parsing cron expressions is a difficult problem in itself, so I'll be using a library to help me do that rather than roll my own. And I'll be using various Eventide packages for whatever reason: clock, log, dependency, etc., mostly for mechanical and convenience things. A small disclaimer: what we code today won't be what I would term as production ready. I'm sure it would work passably well, but I still wouldn't stick it in production without iterating on the code a couple of times. Nevertheless, let's do this and see what we get. If you want to use this for your own project, I'm obviously not going to stop you. Let's go over briefly what the actor model is. The actor model is a mathematical model for concurrent computation. Instead of having to deal with threads and mutexes and locks and so forth, we have actors. Actors send messages and handle incoming messages. In many ways, it's very similar to object oriented programming. Each actor has an address and a mailbox you send messages to. And because they're isolated from one another, all they can do is pass messages to each other. Messages are sent asynchronously to these mailboxes where they're stored and processed sequentially or handled. In handling a message, an actor can 1. Send messages to other actors, 2. Create new actors, and 3. Mutate its own state. And that's a very, very, very brief overview of the actor model. Other places will have gone over it in more detail, but that place is not here. Here, I'm mostly about applying these concepts practically. In any case, let's get started. I already have a project skeleton. If you really want to see me set up a project skeleton, watch one of my earlier tutorials. Just a couple of things to note. We have a gemspec file, which already has our dependencies loaded up. We have our test directory. I'm not going to write too many automated tests, but we will be doing extensive interactive testing. And we need a lib directory. And let me add our loader file. And our control file. Before we begin actually coding, I want to define how the scheduler API will work. So let's say we have our schedule here. I want to be able to include the cron scheduler module and define different tasks with their own cron expressions. The idea being that the task will actuate when the cron expression is true. So let's start by building a basic scheduler actor. Right now we want to require the actor library and load up our cron scheduler file. Then we want to go ahead and build this. So the cron scheduler module will be included. And each class that includes this module will include the actor module, which now makes this an actor. When we start an actor, a start message is sent to it. This will actuate the build or new constructor and then handle the start message. Let's go ahead and add some logging. And we're going to have to add it here to our loader file. So we're handling a start message. Next, we want to run this. Supervisors are used to keep track of all the actors and provide graceful shutdowns for any crashed actors. Supervisors also have signal trapping we can use to shut down the process, but we can also use these to send messages to our actors. So I'm going to write a script that starts a supervisor, and within that supervisor, we start our scheduler actor. So we have our supervisor that starts, and it's trapping a int signal. And within this supervisor, we start our schedule. Let's go ahead and test that. Let's go ahead and cd into our cron scheduler directory. And I think we need to install our gems first. Next, let's go ahead and chmod our test script. And run it. Let's go ahead and see what's wrong with this. Let's try that again. I seem to have a couple of typos here. Let's go ahead and comment this out. We also need to fix this, and that should work. As you can see, our start message was handled on the scheduler actor. But we also want to send messages to these actors. As I mentioned before, we can trap signals. Here, I'm going to use the continue signal. What we're going to do is have a message and send it to the scheduler. And now we need a scheduler address, which we should be able to get here. Okay, let's load the clock library. And handle the dispatch message. Let's first define the dispatch message. We'll just make it a struct. And we also need to include the actor messaging message module. Now let's handle that message. All right, let's go ahead and test that. And I'm going to open up a new terminal window. But first, let's copy this process ID. And the continue signal is in 18. And as you can see, we trapped the continue signal, and in doing so, we sent the dispatch message to the scheduler actor. Next, we want to define a schedule macro. So we want to uncomment this. And we want to define a scheduler schedule macro.rb. Okay, let's define this. We want to define it with a cron expression and a callable. And we'll alias this as schedule macro. And let's go ahead and test that. All right, I forgot to load it up in our loader file. And I need to actually include this, or rather extend the schedule macro. Okay. Next, we want to store these schedules into some sort of task registry. So let's go ahead and define it. Task registry. And then when they use this macro, it will register the task. And now we need a task registry class. Let's include the log dependency. So we need an array of tasks. And then we need to define the register method. And then I'll just add each of these to the tasks array. Okay, let's see if I broke anything. Yes, I did. Let's actually change this to debug. And let's check to see if I did that with other logs. Yeah. Debug. Okay. Let's try and see if that fixed it. Okay, and we can see we are registering our task. Now, I kind of want to have a bunch of actors passing messages to each other in a system with each task represented by an actor, a task actor. So let's go ahead and do that. So we need to include actor and log dependency. And we want the cron expression and the callable. Let's then create our build factory method. Okay, then let's handle our start message. Now we need to load this file, I believe. Oh, let's also create a log class. And this will allow us to group all the tags under a single tag cron for any of our modules that are using the log dependency. Now let's go here and let's go ahead and define our tasks. And then for each task in the task registry, we want to start a task actor and add the task address to our array. think I need to define each on the task registry. There we go. And let's see if I broke anything with that. That actually looks like it's correct. Let me go ahead and commit this. Next, what I think we need to do is actuate each task when a dispatch message is sent. So let's go ahead and do that. So let's handle a dispatch message. And we'll just call the callable. And then in our scheduler, inside of our dispatch message, we pass this dispatch message to each task. And this send method is actually a convenience method for this module right here, the send module. All right, I think this is correct. Let's go ahead and test this. Copy this process ID. And then kill-18, paste the process ID. Undefined local variable or method logger for cron scheduler controls schedule example class. Oh, I think I know what this is. So if we go to our task and we go to when we actuate the callable, this callable isn't being run in the same context as our schedule class right here. So we can remedy that. Let's go to our scheduler. When we start each task, we can actually pass in ourself. And then when we go to our task, when we're building it, we can pass in the scheduler. And then we declare a dependency. And then we include the dependency module. And I think that works. Let's copy this. Whoops. Oh, right. I didn't actually do anything with this. All right. So let's comment this out. And then using our scheduler, we'll call the instance exec method on our callable. And that should work. Let's copy this. Oops, what happened? Oh, I must have closed it prematurely. Okay, we can see that the hello world text log was actuated, which is what we want. Next, I kind of want to make sure all callables are executable. Right now we have a proc here, but what about lambdas, blocks, objects, and classes, and so forth? So let's go ahead and do that. I'll copy this, paste, paste, paste. Lambda. And let's change this. Lambda. And we'll change this to block. And here we want to declare a class. We'll just make it foo. And here we want to declare an object, which we'll make bar. Let's go ahead and declare class foo, include the log dependency, and then do a def.self.call, instance equals new. Next, for our bar class, okay, let's go ahead and test this. Oops, I think I have a syntax error. Yeah. Okay, so we need to change the schedule macro to accept a block. So here we're going to make this nillable, and we'll add a block argument, which we want to pass into the registry. And then within the task registry, we want to add a block. And add that here. And then within the scheduler, we want to add that here. And then within the task, we want to add this here and here. And then we'll set it to callable if the block is given. And here we want to actuate the callable directly rather than use instance exec if it's a class or an object. Luckily for us, procs, lambdas, and blocks are considered procs according to Ruby. So we can do something like this. Let's go ahead and test this. Copy this. And we can see that it worked. Block, proc, lambda, foo, and bar. Now, finally, we want to actuate the tasks on a timer. So let's build that. Let's include the actor and log dependency. And actually, we'll need dependency as well. Let me make sure that is loaded here. Okay, dependency clock. And for our build constructor, There we go. So for a simple timer, we just handle the start message and we send a tick message. And then when we handle the tick message, we go ahead and log it. And then we send a next message. And then we handle the next message. And then we sleep for a certain amount of time. And then we send a tick message. And I think I'll define our sleep tick as about a millisecond. And then we just go to our scheduler and start the timer. There we go. Let's go ahead and test this. Oops, I forgot to add this to our loader file. Okay, let's test this once more. Okay, so that seems to work. But I want to make sure we tick on the second mark, so when it's at 0 seconds. So to do that, I'm going to need a timestamp. And I want to skip this tick debug message and sleep when it's near the second. And let's define that down here. So let's say that it's near the 0 threshold when the timestamp dot microseconds is less than a certain threshold. And that threshold can be 5,000. Let's go ahead and test this. Okay, so the tick is actuating near the 0 second mark, or rather the 0 microsecond mark, or rather the 0 millisecond mark, or whatever. Close enough. But it's actuating multiple times each second. So the 20-second mark has 4 right now, and we only want 1. So here, I think we want to keep track of when we last ticked and then only tick again once a certain amount of time has elapsed. So let's add a attribute called last tick. And then we return next unless a certain amount of time has elapsed. And then once it has, we set last tick equals to timestamp. And then let's define it here. I think we want to return true if last tick is nil. Otherwise, we calculate how much time has elapsed. I'm going to convert these to floats. And I'm going to round by a certain precision. And because we're working with floats, the precision can be a little bit off. So I'm going to make sure that time elapsed minus tick frequency, which will be 1 second. And the absolute value of that is less than or equal to my tick delta. So let me define these constants. Our precision will equal to 2. Tick frequency will equal to 1.0. And tick delta will equal to 0.01. All right, let's go over this. So we're subtracting timestamp from the last tick saved, and we're rounding that to the nearest 2 decimal places. And we're subtracting the time elapsed from 1.0 and getting the absolute value of that, and then checking to see if that is less than or equal to tick delta. Okay, let's go ahead and test this. All right, I think it works. As you can see, the ticks are actuating near 0 each second. Let me go ahead and commit this. Next, we want to send a dispatch message to our scheduler actor on the minute mark. And I think we can do that pretty simply. So we'll skip unless we're near 0 seconds. And that will look like this. So we still want the tick to go through every second, but then we want to send a dispatch message on the 0 second mark every minute. So actually this should go below the tick. Then let's send a dispatch message. And let's first send it to the timer or ourselves. And let's log it. I think that looks good. Okay, as you can see, we have a heartbeat log on the 0 second mark of the minute. Let me go ahead and commit this. Now we want to send a dispatch message to the scheduler. But in order to do that, we need to pass in the scheduler address to the timer, which we can do here. And then we need to modify the timer build constructor to accept the scheduler address. And then we go down to our dispatch message. And we send the dispatch message to the scheduler. Okay, let's go ahead and test that. All right, awesome. Our tasks actuated on the minute mark, which is what we wanted. Now we have to have each task actually evaluate the cron expression. Let me go ahead and commit these changes. First, let's go ahead and require the parse-cron library. Then let's go to our task. We want to evaluate our timestamp from the cron expression. And we actually need to define that here. And then when we start our task, we want to set the next timestamp. And the same after we actuate our callable. And then we want to return unless our timestamp matches our next timestamp. So let's define the matches predicate. And this is pretty straightforward. We just compare the year, month, day, hour, and minute. And I think that is correct. Let's go ahead and test that. Oh, oops, I didn't define the clock dependency. Okay, let's go ahead and test this now. And as you can see, our next timestamps are being set. And let's see if they actuate. Oops. Oh, okay, I think I know what this is. Here we go. And let's try this again. And as you can see, our task actuated and the next timestamps were set. Let's actually go ahead and see if we could do a bit of a more complicated cron expression. Right now, we'll try for the 43 mark. All right, let's go ahead and test this. Okay, our hourly task did actuate, And our next timestamp was set to 1 hour later, which is what we wanted. All right, let me go ahead and commit all this. And just for fun, let's see how many threads our scheduler is creating. Oof, that's quite a few threads. One's for our supervisor, one's probably for our scheduler, timer, and each of the tasks, of which there are 6, right? 1, 2, 3, 4, 5, 6. Yeah, 6. Folks, that's all I've got for today. I hope this was helpful to you. I thought it was pretty fun to build. Did we need to use the actor model instead of coding it synchronously? Indeterminate. In any case, the code will be available on GitHub if you'd like to take a look. If you have any questions for me, be sure to check out my website, josephchoe.com. I'm also on Twitter and GitHub and a lot of other social networks. Thanks for watching.